Now let's take a look at polyatomic ions. These are ions because they have unequal number of electrons and protons as indicated by these charges. And we'll learn in later chapters why this is stable. And it is stable, which is why they exist. Now by polyatomic ion, we mean that each ion consists of more than one atom. In this case, consists of 7 atoms. Here, 4 atoms. But all you need are 2 or more. This polyatomic ion only has 2 atoms. Now, it is very important that you can recognize these polyatomic ions. I highly recommend memorizing them by placing the name on one side of a 3x5 card and the formula on the other. If you can't memorize them, you'll need to have them handy because I won't be giving you the name and the formula. I'll give you the name and expect you to know the formula, or give you the formula and expect you to know the name. Now let's look at these formulas here. Remember, the subscripts tell you the number of atoms. So this polyatomic ion known as acetate has 2 carbon atoms always, 3 hydrogen atoms always, 2 oxygen atoms always, and a -1 charge. Let's look down here at hydrogen carbonate, also known as bicarbonate. 1 hydrogen, 1 carbon, 3 oxygen, and a charge of -1. It's very important that you don't get the subscript and the charge mixed up. They are very distinct, but each one important. As I pointed out earlier, most of the polyatomic ions have negative charges. There is one that has a positive charge and therefore is a cation. This is ammonium. We know from writing formulas that if a formula contains more than one polyatomic ion, the polyatomic ion must be enclosed in parentheses. So let's go ahead and just jump into the deep end and see if you can figure out what the formulas for these 2 ionic compounds would be. The first one, aluminum ion with a sulfate ion, and the second one, chromium 2 ion with hydrogen carbonate. So pause the slide and see if you can come up with the correct formula. So let's look at our first example, the aluminum ion and sulfate. Aluminum is what your book calls a type 1, always has the same charge of +3, and sulfate, if we look back at our chart, has a charge of -2. And I've highlighted our charges because those are what determine our ratio, the charges, not the subscript. We're going to use the same technique that we always use, which is take down our number and place it as a subscript. Now, what this turns out to be is 2 aluminums and 3 sulfates. Now, if I just leave the 3 there, what that means is I have 43 oxygens and 1 sulfur, and that's not correct. So this is why we put parentheses around our polyatomic ion, and this 3 outside the parentheses means I have 3 sulfates. Now let's check our charges to make sure that they cancel out. With my aluminums, I have 2. Each aluminum always has a charge of +3, so I have a total of +6. With my sulfate, I have 3 of them. Each sulfate has a charge of -2, so I have a total of -6. These charges cancel out, so my formula is correct. So let's look at our next example, chromium 2 and hydrogen carbonate. Chromium 2 is this ion, chromium with a +2 charge, that's what the Roman numeral stands for, and hydrogen carbonate, according to our table, is HCO3 with a -1 charge. So we're going to take our numbers over, and that gives us a ratio. I have 1 carbon and 2 hydrogen carbonates. But again, I don't have 32, I have 2 of the total hydrogen carbonate. Anytime we have more than one polyatomic ion, we need to put parentheses around it. Let me write these a little closer. There we go. There's the correct formula. And let's do our charge check. Chromium has a total charge of +2. Each hydrogen carbonate has a charge of -1, so these do cancel out and our formula is correct. Let's do one more. Figure out the formula of calcium sulfate. Okay, so here there are two ways you can figure this out. You could see from the get-go that calcium and sulfate have charges that cancel out. In that case, it's going to be a 1-to-1 ratio. If we have one polyatomic ion, we do not put our parentheses around it. However, if you did it the other way, which is bringing down the subscripts, you would have put the parentheses around the sulfate because there were two of them. However, we always want to check to see if our two subscripts can be reducible, and they can be. If they can be reduced, and they can be. 2 and 2 have a common factor of 2. So, once we divide out our 2, we end up with 1 calcium and 1 sulfate. Regardless of the method you went around it, you went to figure it out, by the end you'll have the same formula, calcium sulfate. One polyatomic ion in a formula does not require parentheses, and if you put parentheses around it, it will be considered wrong. So you only need parentheses if you have more than one polyatomic ion in a formula. So pause the slide and go ahead and name these 3 compounds. This one is made up of it's made up of a polyatomic ion and a monoatomic ion. And remember, we just write the name of the cation and the name of the anion. So the name of this cation is ammonium, and the name of this anion is chloride. The name of this cation is calcium. It doesn't need a charge because it always has a charge of +2. And according to our chart, the name of this polyatomic ion is acetate. So the name of this compound is calcium acetate. Now here we have nitrate as our anion, but we've got to figure out the charge of our copper because copper is a type 2 metal, meaning it has a variable charge. So we're going to figure out the charge of our copper the same way that we always do. We look to our anions. According to our table, nitrate always has a charge of -1. And my formula says I have 2 nitrates. So therefore, my total charge is -2. Thus, the charge of my copper must be +2. So the correct name of this is copper 2 nitrate. Copper 2 is the name of my cation, and nitrate is the name of my anion.